In preparing for finding derivatives without having to use the long formula, we're going to talk just a little bit about negative and fractional exponents. It's something you've done before, but I think I need to remind you of it. I think it will help you, especially once we do more with derivatives. So there's two rules you sort of need to know and memorize. If you have something raised to a negative power, that is the same as bringing that to the bottom, x to the a, without the power. The 1 is coming from the understood 1 that's in front right there. If there was another number, that number would go on top. So that's if you have a negative power. If you have a fractional power or a rational power, the bottom of it, the a, is the part that goes in the root. The top part is the power that it's raised to. So x will go in the inside of the square root, inside of the radical, and b will be the power. Now, you could write that also as square root of a, or the eighth root of x, and then raised to the b. That is another way that you could rewrite that. Now, we're just going to look at a bunch of examples. So, the first few examples, I want to rewrite the answer without negatives, so no negatives and no fractional exponents. So, on the first one, it has a negative power. I can just bring that to the bottom and make it 1 over x to the third. On the next one, since I have a 4 on the top, the 4 will stay on the top, and then I just bring my x squared to the bottom and change it. It's not negative anymore when it goes to the bottom. Alright, number 3. Alright, the part that has the negative, that goes to the bottom. Everything else stays. This negative that's outside, that doesn't change anything. It just means that the answer is negative, so it's negative 5x and then over y to the third. Alright, number 4. Okay, I know there's going to be a 3, and I know there's going to be a radical because of that fractional power. The 2 is the number that goes inside the radical, so it means square root. The 3 is the power, so it's x to the third. Now, you can write the 2 in there, or just remember that any time that there's not a number inside of there, that's understood to be a 2. Number 5. Alright, the negative 4 it's just a number, it comes outside. Alright, 5 is the root, so 5 goes inside the root. 4 is the power, so we have x to the fourth. Alright, number 6. Okay, the 5 is going to stay where it is. Alright, on the power here for x, I have a negative power and I have a fraction. The negative means I'm going to put it on the bottom. The fraction means it's a root. So it's going to be a cube root of x to the first, since that's a 1, and it's on the bottom because of the negative power. Alright, when you have 4x in parentheses to the 1/2, 4 will be raised to the 1/2, and then x will be raised to the 1/2. So it sort of looks like this: 4 to the 1/2, x to the 1/2. Well, then I want to work it out because I don't want these fractional powers. That's the same as the 2 on the bottom means it's a square root. So square root of 4 and square root of x. I know square root of 4, it's 2. So I get 2 square root of x. Alright, the next few examples, I want to rewrite them with the negative and fractional exponents. So number 8, okay, that's a root, so I know it's going to be x to a power. There's an understood 1 there, so it's going to be 1 over 5. Okay, the next one, there'll be a 5. You don't have to do anything with the 5, and then x, and then 2 over 3. Anytime you have those radicals, we know we're having a fractional power. Number 10. Alright, a 1 on top, so that's just a 1 with the answer. And then the 5 is on the bottom as the power, so it would be x to the negative 5th. Number 11. I can go ahead and reduce, make that 2. 4 divided by 2 is 2 if I want to. And then my x is on the bottom with a negative power. Alright, number 12. Be really, really careful here. This is the thing I need to change. Everything else needs to stay the same. So I'm going to leave it as 1/2 and then make x to the negative 1. What I want you to realize here is that these two problems are different. 2x to the negative 1 is really a 2 on the top. 1/2 x to the negative 1 is really a 2 on the bottom. Now, I also want you to realize that if you have 2x to the negative 1, that is the same as one of these. What actually happens here is that's 2 to the negative 1 and x to the negative 1. So that's the same as 1 over 2x. So 2x to the negative 1 in parentheses is the same as number 12. Just be really, really careful, because if I want the 2 on the bottom, I have to put it in parentheses, whereas here I don't want the 2 on the bottom, so it's just outside of the x. Alright, 13. This one's a little different because I need to combine the x's. So what I'm going to do first is I'm going to change the second one to x to the 1/3, because it's a cube root. When I'm timesing x's together, I add exponents, so I'm adding 1 plus 1/3. That's 4/3. And so there's my answer. If I was raising something to a power, I would multiply, but when I'm multiplying, I add exponents. Alright, so this is 3x over, I'm going to go ahead and change that to x to the 1/2. When you're dividing, you subtract exponents. So the 3 is there. This is like a 1 right there, so 1 minus 1/2 is 1/2, so this would be x to the 1/2. Alright, some other things that you can do with these problems are problems like this. These are things that you're just sort of expected to know without a calculator. You can always think about it and then find the answer, but you don't have to like get the answer. You don't have to rewrite it necessarily. So 8 to the 2/3 means, okay, that's a cube root, and then the 2 is a power, so I can put it there. The other way I can write it is like this, and sometimes one way is easier than the other. It does to me look like this is easier because I know that the cube root of 8 is 2, because 2 times 2 times 2 is 8. So that would be 2 squared, which is 4. Now if I did this other one, that's the cube root of 64, and then I could figure it out and realize that that's 4, because 4 times 4 times 4 is 64. But either of those ways will work. You just do whichever one you think is easier. Number 16, 5 to the 0 power is 1. Anything to the 0 power except for 0 is 1 always. Just wanted to tell you that. Alright, negative 1 to the 1/3. Anytime you have a negative raised to an odd power or a fractional odd power, you always still get a negative. Now, I want you to be aware that these two things are technically different. Now, that there are the same answer here because we have an odd power, but on the way that 17 is written, the negative 1 is raised to the 1/3. On the way it's written here, only the 1 is raised to the 1/3, and then you put a negative on it. So just be careful about that. And then number 18, 5 to the negative 2. You want to bring that to the bottom, and then you get 1 over 25. So those are just some examples of things that you'll see later on where you do need to be able to work those out, but you can't use a calculator on them. So I just wanted to remind you of those concepts.